For the ones that can and that are part of the University of Arizona, I would like to ask for your University of Arizona's ID. So for example, mine is cozy@arizona.edu, and you can either send it to me in a private message or a private a private Zoom message, or if you can send it to the group. Why that is because all of a sudden I can add you to the Data Lab HPC group, which is going to be part of today. So I have added a number of you. I just want to double check before we actually get started that you can all be on board. So just please give me a minute. Thank you. Um, just double checking. Oh, I need to. Would be extremely useful to have your phone by you today because you'll have to dual authenticate. Okay, let's see. Oh, I'm missing you. Okay. I believe everybody else is on board. Fantastic. Okay. All right. That said, we can probably get started. Okay, so today the topic of discussion will be a little bit of a, wouldn't call it a mixed bag exactly. They go hand in hand. And the idea is to cover how to run containers onto the HPC. And there is a number of techniques that are necessary to understand before actually using these containers. So whilst I was writing up the lesson, it occurred to me that the lesson wouldn't make sense unless you know the basics. So essentially, it's nice to have a car and to press the accelerator and have the car move, but it's nicer knowing how the car moves. What are the internal parts that make the car move? And so the lesson is going to be structured where the first half we are going to cover how to use the HPC, and the second half of the lesson is how can you run containers on the HPC and why we are using a specific type of technology. That said, for some of you, this might be a refresher because I know a lot of you do use the HPC. And if it is new content, then I'm glad that I can get it to you. So I'm going to be sharing my screen. I'm going to share my entire desktop in this case because towards the second half, we're going to be using the command line interface. So if you do want to follow along with the notes, here are the notes on the Foss website itself. All right, so today's topic of discussion will be Singularity and Slurms, or Singularity, Aptainer, Slurm, and the HPC, which way you really want to understand all of it. And the expected outputs are going to be able to log onto the HPC and start an interactive node. What is an interactive node? We are going to be covering soon. Know the basics of HPC-related commands. Execute containers through Singularity, Aptainer, being able to search and load specific software. I had in plan to show you a Nextflow script running onto the HPC, but then I realized that this probably is going to be a lot of information, and if it is new to you, then I don't want to overload. So for the last 3-4 classes, we very much talked about containerization technology, how to use Docker, how to use Docker to download and interact with containers, and how to build your own Docker images so that you can use at a later time. However, there is difficulties when it comes to running Docker containers on large compute such the HPC, and there is a reason, and that reason is permissions. Docker very much requires pseudo privileges, and pseudo privileges means that you need to be owning your PC, owning your machine in order to run that specific piece of software. For example, if you want to install something on your computer might ask you, hey, I need your password. And all of a sudden, you know your password and you can install it. But when it comes to an HPC, a high power computing, you are not the owner of this machine. You're not the owner of all of these nodes. And all of a sudden, you are left with having to ask the hardware team running the HPC to please install a specific software for you so that you can do your research. But what if there is a workaround to that? And the folks behind Singularity and Aptainer, and I'm going to make the distinction between the two later on, thought of using container technology so that you only have to install one piece of software, and that is Singularity Aptainer, to run all of the containers that you require. And that to me is magic. Okay, we can do that. But how do we do that? Before we jump into Aptainer Singularity, I'm going to talk a little bit of the HPC and how trying to understand the HPC could be challenging. First of all, I would like to see a couple of hands go up or a couple of check marks. If you do understand how the HPC works, give me a green check. If you don't know how the HPC works, give me a red X if you have used it or not used it as well. All right, I see a lot of reds and some greens. That gives me something to go with. The first thing that we're going to start with is a 10,000 foot of the HPC. The discussion of the actual hardware, so what the hardware looks like, how fast the HPC's systems here at the U of A are going to be covered from Chris Reedy next week. But today I want to show you how you can utilize the HPC and how you can understand it. I'm going to scroll down a little bit because this is a good image that kind of shows you how the HPC looks like. The HPC itself, the high power computing, is this part right here. It's literally, if you've never been there, it's a room full of computers, of servers that talk to one another. For you, in order to use all of this compute, you have to go through two layers of quote unquote security. The first is the Bastion host, and the Bastion host is called that because it prevents attacks coming from the outside world onto the HPC. It prevents users to overload the HPC itself. And well, for you, in order to log in, you will require a dual factor authentication to first get into the Bastion node, and from there get into the login node. I'm going to put it into practice. You are welcome to follow along. And for that, I need to make this a little bit smaller and to bring up my terminal. Make this a lot bigger so you can also see. So first of all, what we want to do is to get ourselves onto the Bastion node and from there onto the login node. And how do I do that? To do that, we will need to use something called SSH. We have learned about SSH in previous instances, such as in GitHub, or you may have used SSH in order to connect to someone else's computer. So in order for you to connect to the HPC, you will do SSH, your specific net ID. And I'm sorry, Kurt, that this will only function if you are a U of A affiliated person. HPC at arizona.edu. And I'm also going to type it over here, SSH net ID at hpc.arizona.edu. I also have these right over here if you want to follow along. We're going to press enter. It's going to ask for your University of Arizona password. And it's then going to prompt, oh no. Okay, I'm going to try again, and this time type my password correctly. And then it's going to ask me for a dual push. And at this case, I'm going to press 1. And it's going to send to my phone the request for authentication. And finally, I should be through. Okay, great. So I wanted to get to this point before anything, because here what it tells me is a number of information, such as when you last failed to log in, literally the date when you last failed to log in, how you were trying to get in. And at this point, we're not at the HPC yet. We are at the Bastion host. The Bastion host now, sorry, we are past the Bastion host. We're now at the login node, where we can choose what system we want to use. Type shell to access the job submission host for all environments. But what does this mean? Fantastic, cool. This means that we are being asked to choose what system to use. Notice how I haven't chosen the system yet, but if I type in shell, it's going to give me 3 choices. It's going to give me the choice of Puma, Ocelote, and El Gato. And these are the 3 clusters that we have here at the U of A. And although it does look like a room full of computers, it's actually a room full of 3 different clusters. Let's just imagine it that the first 3 rows are Puma, the other next 2 rows are Ocelote, and the last row right here is El Gato. When it comes to choosing a system, I would strongly suggest going for something that's not too powerful or not powerful at all, and that puts us right at Ocelote. And Ocelot is kind of like the middle child over here. It was acquired in 2016. It's not the fastest. It has less than half the RAM than Puma does. It has many GPUs, many GPU cores, but at the same time, they're not as fast as the ones from Puma. I don't want to get into the too much details of, for example, how many cores there are. But for you right now, it's important to understand Ocelote is kind of like the middle child. The oldest child is El Gato. We're coming around to it being roughly 10 years old. And it's gone through elementary school. It has 16 cores, and that is very little. He has a maximum of 64 gigabytes of RAM, and they had to remove the GPUs because NVIDIA dropped the support for them. So Elgato is great if you want quick compute that doesn't require a lot of energy. Meanwhile, Puma is the newest arrived, and it's roughly 4 years old, and is, well, the fastest, the biggest, the strongest. I had the pleasure of testing Puma when nobody else was on Puma, and it was so incredibly fast. And then everybody joined in, and it was so difficult to get a node. So that was a lot of words just to say Puma is the fastest, Ocelot is in the middle, and Elgato is the slowest. For what we want to do today, I think we could get a node on Ocelote on Elgato. I'm gonna go for Ocelote. But I just wanted to show you where you are in the entire system. We have gone through connecting to the Bastion host, doing the two-factor authentication, and then getting onto the login node where we are asked for choosing what system we want. There is a question from Chris. What is our password for SSHing into this? How do we get this up if we just got our accounts set up with HPC? Okay, so everybody on campus, regardless of whether you have a PI or not, should have access to the HPC. Your password is your University of Arizona password. So when you, for example, go to UAccess and ask for a student center, it's going to ask for WebAuth. I'm going to sign out and try to sign in again. Come on. Oh my God. Let's try that again. Seems like it doesn't want to allow me to get into my student center. Well, the password is the one that you use for logging in onto, for example, the Wi-Fi, or logging in onto the UAccess pages. And you haven't just gotten your account for the HPC. What I did was that I added you guys to the Data Lab HPC allocations. So everybody has access to the HPC. You now have fuel to burn. I hope that answers your question, Chris. And let me know if actually, I should probably check in with everybody. Were you able to get to this screen here? Green checkmark for yes, X for a no, or a thumb up, Sarah. That works too. That's interesting. Shashank brings up a good point. It's the same password, but I think, Shashank, that Chris's issue right now is that there have been too many authentication failures, and therefore the system is not allowing Chris to get back in. So, Chris, you might have to wait a little bit, give it 10 minutes, perhaps. Will that be okay? Okay, cool. You need to wait 15 minutes. If you just created your account, it takes time before you can log in. Well, the thing is, your account has already been created. Now you have fuel to burn, but I guess we just wait. Okay, Shashank asks to try the web version. If I wasn't going to try the web version so far, but um, oh, I'm typing it out. Open on demand.hpc.arizona.edu. This is the, oh, I didn't want it to redirect me already, but this is the web version. ood.hpc.arizona.edu stands for Open On Demand. And what Open On Demand does is that it allows you to request for specific clusters, so shell access, run specific jobs, look at the files, and also look at specific apps that you can start. Okay, so if that works for you, see if you can get shell access and you should be on board with everybody else as well. Okay, so we're now we should all be at the login node, and we are now asked to select which node you want to use. I mentioned earlier, I'm going to go for Ocelote. And as you can see here, it changes from Puma to Ocelote, which tells me that, hey, I am in Ocelote right now. Fantastic. I'm gonna do ls right here. You may not have a bunch of these files. As a matter of fact, I'm going to delete all of the files that starts with SIF, since we are going to go through these exercises later, and all of the files that are SIMG. And that will leave me with only two folders, my pre-2024 work and on demand. If you're confused, what happened here is that I asked to remove star is called a wildcard, and I removed all of the files that end with SIF and all of the files that end with SIMG. Be careful when you use RM. There is no going back. If you do RM-F, there is no trash. So just be careful when you use RM. Okay, great, fantastic. You are now in the login node, and you have chosen what system to use. What this means is that now you can launch jobs, because the HPC is not exactly like a normal computer where you can open up an application and start doing math on that specific application. For example, I'm going to try to run R, and R doesn't exist. I'm going to try to use singularity, and singularity doesn't exist. What about Aptainer? Aptainer doesn't exist. All of these don't exist. And so the only thing that I can do from here is that I can, one, submit jobs to the cluster, and these jobs will run asynchronously and will let you know when they're done. Or two, ask for an interactive container, an interactive session, which is essentially also a job. But what the interactive session allows you to do is to run software as if it was your own computer. I don't want to get too far ahead. Is it clear so far what we have going on? Cool. We have one thumb up. Katie, everyone's understanding relies on you right now. Okay, thank you. Okay, fantastic. Now that you kind of know what we can do here, the next thing is, okay, we can launch jobs, but how do I know that my job will successfully be launched, and what are my requirements? Essentially, what sort of fuel can I burn in order to launch jobs? For you to understand what resources are available to you, you can start by checking out the allocations, and you do that by doing a very simple command, VA. I don't necessarily remember what VA stands for, but I think it's value of allocations, so VA. And when you press enter, you're going to see a number of quote unquote PIs that are supporting your work. I have been in a couple of other labs, and such as the Lions group and the Frost lab, and now I am assigned to yet another group, which is the data lab. And as you can see, every single one of these labs has roughly 100,000 hours, and these are the allocations that you're allowed to burn, excuse me, per month. There has been some allocations that have been used in the data lab so far this month, and that is between me and Shashank that is on the call. But that will allow you to know how many allocations there are left, how many hours you can burn, and 100,000 hours might sound like it's a lot. Trust me, when you have your coworker, your PI, the postdoc, the master student, the rotating undergrad, these things burn incredibly quickly. So just if you're going to be using the HPC, make sure that you do from time to time check how many allocations are allowed, you have access to by you doing VA. Oh, I typed it and pressed enter again. So one, check how many allocations you have. And two, check how much storage there is for you. And storage on the HPC is broken down into 3 different sections. The first is your specific home folder. And I'm going to do PWD, print working directory, to show that I am in home U12 COSI. You may be in home U4 Mary, or U home U65 Sarah. So the U is just the user where they group you and where to put you. The U12 for me doesn't really mean anything. But just know that in your home folder, you have a limit of 50 gigabytes. If you go to the Open On Demand website that I showed you earlier, it will also show you how much quota you have. For me right now, it seems like I'm running a little bit low. And I should probably go and do some cleanup. But you also have access to your group in /groups, and that is limited to 500 gigabytes. 500 gigabytes, once again, sounds like it's a lot, but between you, your PI, your coworker, your postdoc, it fills up incredibly quickly. And you can check this by going to ls/groups. And if I just do this, it's going to give me a long list of all of the groups that exist. Right now, we are kind of stuck at using group COSI because I had to ask for the specific data lab allocation. So if I were to do ls groups/COSI, it shows that Shashank's folder is here, but anybody that's part of the data lab can create a folder under /group/COSI. We're going to be working and try and see if we can change this onto data lab in the future. But for right now, we're stuck here. And the third one is if you have a PI, likely the PI has submitted a small little manuscript that describes how much data a research project requires, and you can request up to 20 terabytes, and that will sit in X disk. And as you can see here, this is all of the PIs that have submitted a request for at least 20 terabytes of X disk allocation. If I were to scroll back up, where we are right now is the login node. We are going to be doing compute onto the Ocelote nodes, and we are now viewing the shared storage right here at the bottom. I'm a visual person. I like to go back to this specific graph because it allows me to understand a little bit where I am on the HPC. Fantastic. Okay, so now we know about the allocations, so how much we can burn and how much we have burned. Storage, how much we can, where we can put our files in and where we're allowed to. And next is, okay, what does the queue look like? And the queue is essentially all of the jobs that are running on this specific cluster. In order for you to understand, or in order for you to know how many jobs there are in the queue, you have to use a slurm command called sq. So if you type in sq, you have now this, I'm gonna make this smaller, really long output of hundreds of lines, and you can essentially see everybody that's running something. I'm gonna press Control C and it gets me all the way to the bottom. There is a couple of best practices when it comes to sq. The first is sq/head -n10. This will only show the first 10. And if you don't know what I'm doing here, is that I'm taking the output of sq and quote unquote piping it, so taking it and putting into something else. The next command is head -n10, which shows the first 10 rows. And I wanted to do this because it tells us a little bit of what we're seeing. And what we're seeing here is a specific job ID. So the job ID of this Krishna's person is 2890485. And this job ID is important because it's the ID that you will need in order to cancel, in order to restart that specific job. So the job ID is important for your compute, to understand your compute. And then you have the next is partition. Partition is essentially what was the name? What submission type you are running. So you have windfall, which is you are at the back, you're waiting for some compute to open up in order for you to use the HPC. You have standard, which puts you in the standard queue. So see this as having paid for the ticket, and it's a little bit of like an expressed line. And then you have high priority. You are the VIP. You essentially get ahead of everyone, and it does, however, burn more hours in comparison to standard. And windfall, I think, burns almost nothing. People that do know HPC, do let me know if I'm saying something wrong. Then you have the name of that specific submission. You have who has submitted this job. You have the status. So I'm not sure what PD is. I think it just means that it's waiting for that specific compute to get free. And then you have R, which means that it is running. You have how many days it has been running for, or how many hours. 00 obviously hasn't run yet. Free means that it has been running for 3 days, 2 hours, 31 minutes, and 35 seconds. This job right here has been running for 8 minutes and 40. Then you have nodes, how many nodes this specific job is running on. And I don't really need to go into the node list section, but is what node it is running. Is this node dependent from another node? We're not going to touch base. We're not going to go into too many details on the node list, but the first important pending queue. Thank you, Shashank. The first 5, I believe, 1, 2, 3, 4, 5, 6, 7. The first 7 are the more important columns that you should remember. The next thing that I want to point out is these are hundreds of lines of output. So what about you? What about your job? How do you know about your job specifically? You can look for your job, and you can look for your job by doing some command line shell commands such as sq. We have seen the pipe command, and I want to say, for example, sq grep, and I want to grab all of the jobs that, for example, user Theodar is running. Theodar. And this should output all of these jobs that Theodar is running. I can do it like this, or I can do sq use user. Let's do Krishna IG. Seems like, oh no, that's right. Did I misspell? Oh, let's just go Theodar. Theodar. And as you can see, it's the same number of outputs. You can, there is different ways to get to Rome. All roads lead to Rome. So if you have a problem, there is probably multiple ways to fix it. But this is important because all of a sudden you can keep an eye on your job, whichever job you are running. Cool. So now you know how to check on the allocations you have, check on how much space you have, and check how many people are in the queue. Is this a good time to launch your job? Should I be waiting? What partition should I use? Questions so far? If you give me a green check, we can just go right along. Or if you have questions, then fantastic. Just to let you know, I wish I knew all of this before I started doing the HPC, and that's why I'm starting from the very, very basics. Okay, moving on. HPC, slurms, and job submission. So it's slurm, not slurm. If you do enjoy Futurama, then you may know that slurm is the little cola that they drink in Futurama. One of my PIs used to make this joke, and I guess kind of rapped onto me. And slurm stands, the right slurm, this slurm in the beginning, stands for Simple Linux Utility for Resource Management. It's not the best name, but what it essentially is that Slurm is a workload manager and job scheduler. Essentially, it ensures that a specific job is given the right amount of RAM, the right amount of CPUs. If you're using GPUs, the right amount of GPUs, and it goes into a queue, and Slurm also takes care of that specific queue as well. As we did mention a second ago, I'm gonna make this a little bit bigger. There is 2 ways we can submit jobs. Remember, we cannot run compute onto the login node itself because it's a very, very small server. We do, however, require, in order to run jobs, request for a batch script or an interactive node. We don't have to go into too many details on what a batch job looks like today, but a batch job requires specific directives. And here is an example. Let me see if I can get both of these onto the same screen. So on the left, I have what the bash script looks like, and on the right, I have the purpose and explanation of it. So a bash script is script.script. You know, it can be absolutely anything. Script.slurm. But what is important is that it has these specific lines at the beginning. Some of them are optional. I believe all of these are required. And the first one is as batch. So slurm batch. So slurm batch script -- job name. Oh, it seems that I did not add it into the directive itself, but the job name is the name that you want to give it. This is the name that shows up here, Gauss 10, for example, or BE2B. And in this specific case, I wanted to run a small blast job. So you give it a blast name. Sorry, you give it a job name. The second line is the partition. You can set the partition to be windfall. You can set the partition to be high priority standard. Then you have as batch nodes. Unless you know what you're doing, I don't suggest you change it to be more than one. There is going to be a little bit of math involved into it, because all of a sudden you have to count. I'm going to scroll up a little bit here, how many cores there are, how many cores I'm allowed to have. For example, I can ask for 94 cores, but that will be nodes times 1. If you want to have more than 94 cores, then you will have to have 2 nodes with 94 cores. So I don't want to get into too many details about nodes itself. You are safe with just having one. And then you have task per node and CPU per task. These two kind of go hand in hand. Again, I don't suggest you have more than one node and one task, as long as you don't go over the amount of CPUs on that specific system. We are on Ocelote right now, and Ocelote has a number of max of 28 cores. So if you just stick with one node, one task, 28 nodes, you should be fine. Trust me when I say the first time you ever run a real job, you're going to be confused. It's probably going to fail because of how you set up nodes and tasks. And after few tries, you're going to understand how many nodes you want, how many CPUs you want, how many tasks you want. But for learning purposes, keeping things at one will work fantastic. And then how much memory you want, 8 gigabytes. You do need to put G, otherwise it defaults to MB, megabytes, and that is bad. And then you want to add time. You want it in HHMMSS. You want this to be separated by colons. This means that this job is going to run for 2 hours. We haven't talked about it, but this is a good time to bring it up. I can close this one and scroll down over here. Remember just a second ago when I tried to run, for example, Singularity or Apptainer, it wouldn't load because we're on the login node. Well, when we are asking for specific tools and when we are running on a batch job, we can load specific tools using module load commands. Let's say that I want to launch Blast and I want a specific version of Blast. And so if I do module load Blast version 2.12.0, it will load up Blast. And then from there, I all of a sudden have my job written out. I know exactly how many nodes I need, how many CPUs and how much CPU I need, how much memory I require. And now I have my tool ready to go. And I just tell Slurm, hey Slurm, put this in the queue and just let me know when it's done. Ideally, that's what sbatch does. You write a small script. You write a small script with everything that you require. You put it in the queue, and eventually it gets run. To submit a specific script, you require the command sbatch, and you can use the command scancel in order to cancel the script. All of these commands you can find in the documentation. I have put the official documentation link in a number of places. This is going to be incredibly helpful if you ever need help running jobs on Slurm, on the HPC. Okay, but what we actually need to do, are going to be doing today, is launching an interactive node, because we are going to be playing a little bit around with container technology. And although it is possible to launch an containers using an sbatch, we want an interactive node to play around iteratively as we go along. And an interactive node, as I mentioned before, is a node that separates from the asynchronous sbatch jobs, and it gives you the possibility to all of a sudden load all of the files, all of the software that you require on that specific node. It essentially gives you a small computer for you to work on. The quick and dirty way is just to type in interactive. If I type in interactive, it loads up a set of jobs, such as, it goes with the standard. It gives you 4 GB of memory per CPU. It gives you 1 node. You can do 1 task. It runs for an hour. It puts you in Windfall. You don't need to have anyone sponsoring you for this. You can literally just do Windfall and partition Windfall, but this means that you have to wait. You have to wait for that specific job to run, and this can go anywhere between seconds, minutes, and hours. And as I can see here, it just took me a few seconds, and all of a sudden, I have an interactive job. In order for me to exit from the interactive node, I just type in exit, and I am now outside I'm back onto the login node. Because we do have allocations, we want to use those. We want to have a little bit more of a beefy node, and we don't want to be on Windfall. So what are the necessary options required to run this interactive request? So here are the flags that you can use, some of the flags that you can use when requesting for an interactive job. You can use N, default value to 1, but this is the number of CPUs. You can use M, which is the amount of memory per CPU. You can ask for an account group, and this is where you want to use the data lab. And you don't necessarily need this -- partition equal, because if you put your -a flag, it gives you essentially the standard partition. And then you can go ahead and use the -t flag, which sets for how much time you want to run it, and -n, again, the number of nodes. There is no reason for you to put a number bigger than 1 if you're not going to be doing anything bigger. So I've put this together, and it's an interactive job. It's an interactive node request, which asks for 8 cores, 16 gigabytes of RAM, quote unquote, charges the data lab, and it's going to run for a maximum of 2 hours. So my request to you is to copy this and paste it, and just press N. It's going to be putting you into the queue, but as you can see, it was a lot quicker than your Windfall job. The Windfall actually was quite quick itself, but there have been times in the past where it just took forever for it to connect. So now you have your own interactive node, and I'm gonna take a second to see if you guys can get on it, if you are following along. Give me a green check if everything is good, or an X if you're having issues. Also a good time for break. Also a good time for questions if you have any. I see green. Okay, green is good. And okay, so more green, yay. We are now on an interactive node. What are the things that you need to know? Interactive nodes, if you don't do anything with them, I think 15 to 20 minutes is just going to disconnect and give the compute to someone else that may require it. So don't be idle for too long, otherwise you lose your interactive node. And I like to go back to the car. Just because you are in the car and you turn it on, it doesn't mean that there is no fuel being burned. Because you turn on the car, fuel is being used, and therefore you want to do something with it. Don't be idle, don't just burn allocations just because. So you want to do something with the car, and one thing that you can do with the car is understand what tools there are in the car. Let's say that this is your first time getting onto one of those new fancy cars, and whoa, there is a nice little screen on your side and you want to understand what all of these functionalities on the screen are. So to understand what tools are installed in the HPC, you want to use the module commands. We talked about the module commands a second ago. And this is a good time for you to get a hold of what is installed. So these are 5 examples over here on the right. And the first one is module list. And this will list the loaded modules. Auto tools, OHPC, CMake, OpenMPI, and Prune3. These are tools that are already been loaded. But what about module avail, which lists all of the available modules? Sorry, not all of them, but lists modules that you may want to work with. The next one is module spiders, lists all of the modules, not necessarily required, but all of a sudden, you can see some of the tools that perhaps you used. FastQC, if you're doing quality control for genome alignments. Different types of Python, PyMol, different R studios, Salmon. I'm just pointing out the ones that I recognize. Spades, different Julia languages, MATLAB, different versions of MATLAB. And all of a sudden, you have all of these tools that can be called upon. I want to see. Excuse me a second. I'm going to scroll up and down a second. Cool. All right. But then all of a sudden you can try module spider, and this is way more information that you require. But this is all of the possible modules that may have different versions as well. So it's very much module avail on steroids. But what if you want to load one? What do you do? So let's say that I want to load FastQC just because I just saw it earlier. Module, what I will require to do is module load FastQC. It doesn't tell me much, but it has given the shell back to me. And if I were to do module list, I can see that FastQC is now loaded. Woohoo! Lastly is doing module help if you don't know what to do, but I do think that the Confluence wiki has pretty good extensive knowledge on, documentation on using the module command. Great, fantastic, but we're talking about Singularity Obtainer. Do I have to do module Singularity Obtainer, module load Singularity Obtainer? No, it comes with the interactive in Node itself. So if you were to do Obtainer, it runs. If you were to use Singularity, it also runs, and it kind of gives me the same output. What's going on? I'm going to explain it in a second, but what they did is that instead of when you type in Singularity, they are redirecting you to actually use Obtainer. What is going on? What does it mean? I thought we were learning about Singularity today. Well, we're going to be learning about what is going on right after the break. We're going to take a 10-minute break now and let everything kind of sink in a little bit because this was a lot of information. Do come back at 12:10 and let me know if you have questions. So, folks, thank you very much for your attention. I'll see you soon. All right, we are ready to resume. But before we do that, are there any questions that people may want to ask? Are you still guys on the interactive node?
Yes, and I did have a question. Is the time, the expected time, like, is it setting a limit for how long you want the batch to run, or is it saying, or essentially you're allocating resources for that amount of time? So you would have to know how long your program would take.
Yeah, so talking about the batch job first. The batch job, let's say that you allocate 10 hours, and that is the maximum amount of time that job is going to run for. But if your job ends in 1 hour, 2, 4 hours, then it is not going to charge you the extra 6 hours from there. So does that make sense, Sarah?
Yeah, I was just wondering, like, how do you find out how long it will take?
Remember,
the first time you do it.
Yep. Roughly 20 minutes ago, I said the first time you're gonna fail. So it's kind of the same on the same vein where the first few times you do run a specific job, you don't know exactly how much compute you require. You don't know exactly how long you require for the job to run. So there is a little bit of trial and error. If not a little bit, there is a lot of trial and error involved. My first ever job onto the HPC, I gave it a maximum of 24 hours. It was a blast job. It finished in a minute. So it very much is trial and error. How much compute can I request? But I'm hoping that Chris Reedy is going to answer the mathematics behind it more next week. So I believe we can get resumed on the next part of today. So I'm going to be sharing my screen again. Okay, let me open this up. Fantastic. Okay, for the first half of today, we learned how to use the HPC, and hopefully you have a better mental map of the various moving bits of the HPC itself. The next part, and hopefully this is going to be as helpful to you as it was to me in the past, is understanding how to use container technology on the HPC itself. And the container technology on the HPC, not allowing Docker, we very much have one choice left, and that is using Singularity or Apptainer. And to remove the confusion, or maybe to add to the confusion itself, until 2021, Singularity was named Singularity. That was it. There was no difference between Singularity and Apptainer. Apptainer didn't exist yet. In 2021, the organization behind Singularity, Scilabs, created a fork on GitHub of the entire of Singularity and called it Singularity CE, Singularity Community Edition. I just opened it in a new tab, and this is Singularity itself. They have given this copy of Singularity to the world for people to work on and to understand how this works. This is now of the community. It's not being maintained. There is no new releases, but if you want to understand the technology behind Singularity, this is where you go. And they are allowing Singularity CE to be compliant with Foss and for the community to do their things, whilst meanwhile Scilabs itself decided to join something called the Linux Foundation, and these are the people that maintain Linux, these are the people that develop Linux, and rename themselves Apptainer. The reason why they name themselves something different, I'm not really sure. It's just that now we have to go with what they're giving us, and then and Apptainer is the new name. So the two are not necessarily you can't. I like to use the two interchangeably because I grew up on Singularity. There is a lot of people out there that just like to make the difference between Singularity and Apptainer. They are a little bit exchangeable, but for right now, I'm going to go ahead and just use Apptainer going forward. The note that I've put over here is that, once again, Apptainer is great. It's very similar to Docker, but it allows to work onto the HPC because it bypasses the pseudo permissions that Docker requires. There's a little bit of an expandable over here that tells you a little bit more about it. But I think we covered most of the points in here. We do also have a container camp, some of the container camp information from the previous year. This is in case you want to get into knowing a little bit more of Singularity and containers, but we're not going to go into it as much. However, do understand that a lot of this content that you're going to be seeing now does come from there. We're going to run through them as much as we can. Like anything, the first command that you need to know is help. So what we're actually, I'm going to take a step back. The next section, we are going to go through general executable commands, how to run containers and how to interact with containers. So the first part is, what are my general executables? Well, if you do Apptainer help, it gives you, okay, these are the various help commands that I can do. But what it also adds is that if you do help and a specific command, then it tells you about that specific command. So if you were to do Apptainer help build, then it gives you all of the necessary, what are they called? Instructions, like we knew them from Docker. These are your from, these are your CMD entry point. In Apptainer, they don't use from, they use, for example, percentage percentage setup, percentage file. We're not going to be building Singularity Apptainer containers today. What? Okay, we're not going to be building Apptainer's container today, so perhaps Apptainer help pool. Oh, Apptainer help pool is a better example of this. It gives you what options you want to use, and so on and so on. We then can use the search command, so obtainer search, and then that allows you to look into the various, all of the repositories from Apptainer. And for example, Apptainer search, in this case, is TensorFlow. It's going to take a little bit of time. This is one of the things that I don't really like about Apptainer. I'm not really sure where their repositories are. And I like to use Apptainer more like a tool that runs things onto the HPC rather than a tool for developing a specific tool or looking in the Apptainer specific libraries and repositories. However, as you can see, it took a little bit of time. It did output so much information. But the search command is something that you can use in order to search just the Apptainer repositories. Thank you, Carlos. And the next important command is the pool command. So for example, Apptainer pool. And this is the thing about, this is one of the big differences between Docker and Apptainer itself, is that in Apptainer you do have to specify where you're pulling it from. If you use library : / it's pulling from its main library. So pool library, its main repository, sorry, lol cow, and you press enter, it will download. Oh, okay, so I already have downloaded it. It's cached in the system. So it's using the cache system to download it. What I like about it is that there is no, one thing that I like about Apptainer is that when you download a specific image, it puts that image exactly where you're putting it. Because, for example, in Docker, where is the image going? Well, it does go in a specific repository, but in Apptainer, well, it goes right here. So that's one thing I like about it. Brandon says, anyone else get an error about no library client? Oh no. What is the command you're using? Oh no.
I just did the Apptainer search TensorFlow and it said remote has no library client.
Huh. Interesting. What happens if you just do the next command then? So the library lol cow.
I got the same, and it says fatal. In
What?
red. Yeah. But my prompt doesn't have the base in it. So I'm wondering if I didn't pull out of one area before going into another. But yeah, it just says it can't find the library.
Okay. Honestly, I have no idea what's going on right now. Like, I don't know. I don't think I've ever seen that problem before, but if you could paste it and put it on the chat, maybe I can look at it later. It's worth looking at because all of a sudden, okay, I would like to have to keep this at later. And I wanted to ask, what happens if you do this line then? Apptainer pool docker alpine. And the reason why I think this is important is because it is not pulling from an Apptainer library, but it's pulling from Docker, so it doesn't have to fail per se. So I'm wondering if this works for you guys. Didn't fail. Okay. All right, good, because the rest from here on is going to be using things from the Docker repositories and not from the Aptainer repository. Let me check. So what I'm doing right now is that I am looking at all of the hidden files in here, and if I type in ls-a dot aptainer. Okay, maybe if maybe it's in remote.yaml. Let me check. I'm gonna use vim aptainer remote.yaml. Oh, so I do have this, which you guys may not have, which is interesting. If you were to type in, I'm gonna do it right here, and then I'm gonna paste it. It's because I've been using this for so long that maybe I downloaded something in the past and you guys might not have it. Does it give you the same output?
Mine's saying no such file or directory.
Okay. So this might be something that I have obtained in the past. This is not a big issue. It just probably means that you are not able to search the Aptainer registries. But between you and I, the Aptainer registries kind of suck. Shashank is asking me to do something. Aptainer remote list. Ah. What happens if you guys do Aptainer remote list? Do you see something similar to this? Yes. Okay. Honestly, let's not get too frustrated on this. We are not going to be you missing the Scilabs cloud. Yeah, that's probably where I am there were this works on. You may I don't really know, but you may need to specify to look into default remote, and the fact that it is not active. I'm not really sure. But let's not get too flustered onto this specific because we're not gonna go and use the Aptainer libraries and registries as mentioned before. So as long as you're able to run the Docker Aptainer command, then that works fantastic. And I do want to point out that when you do aptainer pool docker dot / alpine, your Docker container, your Docker image is getting downloaded and transformed into a CIF image. CIF stands for Singularity File Image, or Singularity Image File, excuse me. And this is what essentially it transforms. So this is what allows Alpine to run on here. You shouldn't be able to do this if you had Docker installed, for example. Docker will have to do Docker run and everything, but Docker needs you to be the boss. Anyway, we're gonna see this running in just a second. There was something else that I wanted to cover at this point, but perhaps we can just continue. It seems like you guys may not be able to have to access all of these registries, but let's just concentrate in the Docker and the shop registry right now. And we might not even go for shop, we're just probably going to stick with Docker. But before you guys continue, I am going to remove my Aptainer cache. dash f obtainer cache. Oh, excuse me, not error, error. There we go. And that means that my cache is gone and I can use the, I should also be downloading things. So let's try and see if you guys can download the Ubuntu cloud, the Ubuntu using Shub. Should work for me. I want to know whether it works for you as well, since you guys have different settings and tokens. But essentially what this does is that it downloads Ubuntu latest from a different hub. Earlier we downloaded Alpine from Docker. You can also do, you can also give it a different name if you do Aptainer, what was it? Aptainer pool -n or --name Ubuntu. I'm gonna call it 22, actually 24/03/28, today's date, .sif, and then I do have to give it the URI, so shub / singularity singularity hub / Ubuntu. Excuse me, I can't really see. Not sure what is failing right now. Let me try to copy and paste it from here. Usually it works that way. There we go. It does use the cached image that I just downloaded, but it did work. I'm not sure exactly why it didn't work a second ago. Typo and missing. Thank you. You guys, I mentioned you guys in the past. I cannot read. But you can rename things the way that you want them to be named. My own Ubuntu pulled image.sif. So good, fantastic. You can pull things from different libraries, and you can rename them the way that you want on the way down. It's not that as if you have already downloaded it, you can just do MV to rename it. Anyway, we have already pulled an image from Docker Hub, so we're just going to go through this. And we are going to be pulling yet another image from Docker Hub, and we are going to go back to our friends Cowsay. So please do copy this and paste it in the interactive node. You should see something similar to here, where it is copying the blobs and storing signatures, doing a bunch of stuff, and creating eventually the CIF file. You're gonna do ls, and you should have the lol cow _ latest.cif. Give me a thumb up when you are here. Thank you, Brandon. Thank you, Victoria. Coco. Yay, Katie. Okay, that's enough. That's enough for me to go forth. Okay, so Aptainer, very similar to Docker. Thank you, Chris, and thank you, Tuluwanimi. Very similar to Docker. Aptainer has a specific run script or run command, and that is Aptainer run. And then, well, in this specific case, we don't need to put the ID of the image. We just type in the full name of the image itself, and then in this specific case is lol cow latest.cif. And I mean, it should run as expected. It tells me, well, it's giving me the time. Thank you, cow, or that looks like a horse, but that's a cow. And it's also giving me the time again. Why is it not giving me anything that's funny? Underlay of edge local time required more than 5078 bind mounts. That is That shouldn't be an issue. Well, fine. It does run the way that I'm. It does run, but it's not being funny, which is a little bit annoying. I did run this just yesterday. Are you guys having the same issue as me, or are you getting something funny? I'll keep that to myself then. Interesting. All right. Oh, you are absolutely correct. I am running the wrong. I am running the wrong image here. I'm running LOL cow latest, but I shouldn't be running LOL cow latest. I should be running cow say latest, and that should give me something funny. Your sister swims out to meet troop ships. Excuse me. All the modern conveniences, Mark Twain. I'm not sure. No, what's the difference between your latest project and putting wings on an elephant is? Who knows, the elephant might fly. Oh no. Okay, well, same thing as Docker. It does have a run command. And we talked a little bit earlier about specific run scripts that Aptainer has, and these are the commands within the specific container within the specific image in order to run the container. And these are very similar to the entry point, for example, but we're not going to see how this works. Just know that this specific image is being executed through the run script. Very similar to Docker again. You can get a hold of the shell within that specific container, and that is done through the shell command. So if you were to do aptainer shell cow say latest, all of a sudden you have a change in the prompt, although you shouldn't just say, oh, I'm inside a specific container through the change in prompt, but you are now inside that specific container. And type in who am I am still Cozy, and that is incredibly important. So why is this important? Because, for example, when you're running a Docker container and you type in who am I, you will be the user that you have defined within that specific Docker image. But if you use Singularity, all of a sudden you retain who you are. And that allows you to run specific tools that may require a specific user, but all of a sudden the user is retained to be you. And what is the powerful thing coming from Aptainer Singularity is that all of a sudden, all the problems that are coming from Docker, they are kind of boiled down. So this is very much extremely powerful. Another thing that's extremely powerful, we talked about volumes at the end of last week, where you had to use the -v flag in order to create a volume between your Docker image, sorry, your Docker running container and your computer in order to have them talk. But if I am now, quote unquote, inside the Aptainer container, and if I were to do ls, I am seeing things that are on my computer. So all of a sudden, my interactive node is communicating, quote unquote, directly with the Aptainer itself. But I am inside the Aptainer image now, the Aptainer container. It is a little bit confusing, but it is powerful. This is when you do shell, you are creating something called an ephemeral container. Ephemeral container is essentially something that's created to run right here, right now. And as soon as you type in exit, it doesn't exist anymore. Shashank sent me a direct note. I'm just gonna copy and paste it to everybody because this is going to answer a question for everyone. Obtainer search TensorFlow. This will work when the fellows will make a Scilab account. So you need a Scilab account and add a token to their Obtainer setup and activate it. You don't need to do that. Now I know why I have an extra code. I have an extra token. Okay, so now we kind of have an understanding of how Aptainer can be useful and how it is a little bit similar, but also quite different than Docker itself. I'm going to type in exit to get out of the ephemeral container. And the next command that I want to use is the exec command. And exec is a little bit exec is similar to the CMD command in Docker, where you are all of a sudden telling directly to Docker what you want. If I do aptainer exec cowsay_latest, I can then go ahead and tell what I want the latest command to be. Today is overcast, but still is a beautiful day. Seems like it's failing. Fantastic. Why the hell is it? Oh, I know why. It's because I was not calling on the actual command that I required, and that was the command of cowsay. Excuse me. I have, oh my God. Okay, I'm gonna start again. Clear. There we go. And I can start again by saying aptainer exec cowsay, and then ask the program within the container itself. So cowsay to say today is a beautiful day. And now it should work the way that it's supposed to work. Fantastic. Great. But now imagine creating a specific container or a specific image and have an executable and being able to tell that specific executable what you want. So creating, for example, a blast container image, and to be able to say, for example, aptainer exec blast.sif blast, and then all of the required string that comes after blast n, actually, all of the commands that come after that, all of the commands, all the inputs, all of the outputs themselves. So you can create a Docker container, put it in Docker Hub, and all of a sudden pull it through aptainer onto the HPC and have that specific container be executable onto a much powerful environment. I'm going to do Control C right now. I hope that this does make sense so far. And the last command that I wanted to run today was aptainer inspect. And I want to do cowsay. And this is going to give you how it was built, when it was built, who built it, what program it was built. It essentially is a little bit of a hand in helping you understand how you should be running this specific container. Okay. I kind of blew through the second part, and perhaps this is not as clear on how to run containers on the HPC, but hopefully you have a little bit more understanding of how to execute containers onto the HPC. And I'm going to ask you guys for questions. Does this make sense? Is this something that you can envision yourself using in the long run? Do you want to try something by yourself? So I'm going to stop sharing and try and open the floor to you guys to ask questions before we go off and do other things.
Should we quit the job that we started? I think I did. I think when I did exit, I wasn't actually in the Aptainer at all, ever. And so it said relinquishing job allocation, and then the number has been revoked. So I assume that I've quit out of the thing that we did in the first half.
Yep. So if you see something like this, I 1, 6, and 5, that means that you are in the interactive job. And if you type in exit, then you get out of it.
Yeah, okay, good. I'm not there anymore.
Okay, fantastic. All right, well, yes, that was also another thing that I should have probably covered, how to stop your interactive containers. And if you just type in, sorry, your interactive jobs, and if you type in exit, then that does get you out of queue. Let me check one thing. Oh, cool. Well, folks, that was all for me today. That was a lot of information. I don't know whether I covered everything that you may find useful, but if we did cover some more, it might have been a little bit too much. So I will prefer stopping here rather than give you information that you might not be able to retain. And well, you do know where to find me. And please do reach out if you have extra questions. It's a note from Chris. It took over an hour for HPC2 let me try to SSH in again after the authentication failures, and it still won't accept my UA password. But I'll breach the barrier if I need to use it, I suppose. The online version works for whatever reason, and the PowerShell terminal doesn't. Chris, are you on Windows? Okay. I had to do, I was running on the Linux subsystem, and I did sudo apt get, sudo apt, sudo apt update, and sudo apt upgrade and update, and then it worked. I don't know if this is going to work for you. I don't know if this is the same issue, but I was running into a similar problem yesterday. So maybe that could solve it for you. Oh, actually, now that we do have a little bit of time, we talked about the open on demand. And open on demand is, excuse me. Okay, and open on demand is extremely useful if you want to run, for example, our jobs or Jupyter jobs. And the way that this works, I'm just going to copy this and put it in the chat again. And the way that this works is that you go up here on the top where you can ask for apps, and you can look for all the apps that they have. And for example, if you do want to have an interactive Jupyter notebook, just click on this, and you can choose what cluster you want. I'm going to go for Ocelote, and you want to run it for 1 hour. Say I want to have 4 cores running. I want 8 GB per core. you can ask for a GPU. Just know that if you do ask for a GPU, it's going to take some time. Coco, this is for you, okay? And here you can just put data lab, and it's going to put you in standard and click launch. This is for anybody that requires, for example, a Jupyter or running R or MATLAB and require more than, for example, what is given to you through Colab. But also it's quite similar to how you can run things on Cyverse. I usually tell this to people that are part of the University of Arizona. If you have the ability to use the HPC and you know how to, then there is no reason for you to use Cyverse. Don't tell this to my bosses, but you can. So now all of a sudden you can connect to Jupyter, and then all of a sudden you have access to the same folders that you had just on an interactive Jupyter running on the HPC. So I can create new. I want a Python free. Do know that you can't install things on here, but this is a functional Jupyter. HPC is really nice. Yeah, HPC is really nice. Okay, I'm going to leave the site and quit. And if you do, again, you start a job, you turn it off, and you click here to click delete to stop it. But this is really extremely powerful as well. And okay, now I'm going to stop sharing. So, folks, I believe this is all of the information that I have. You guys now know a little bit more how to use the HPC. Next week, Chris Reed is going to come in and talk a little bit more about it, give you more information on how to run things that you may need to run. But folks, I'll see you next week. Have a great week ahead, and party hard, question mark. Take care, folks.
All right, later, McKinley. Thanks, man.
Ciao.
All right, brother.